Okay, we shall discuss a little bit about superelevation before we go to design the superelevation. Okay, what is the superelevation? Now you can see if you are going to see this road. This is I think from Ginnigatten Hattanurili Road. Now can you see that there is some slope here? Okay, it is not the general slope that you are seeing on the road. So why is that? Because this is been super elevated. Now you see when a vehicle is going this way, centrifugal force acts to drag this vehicle away from the center. Okay, so now what we have done is we have super elevated this road area and we have balanced it with a component of weight. Okay, now you can see we'll see whether no, that is in horizontal alignment but I think we have described that here. Here you can see now when this vehicle is coming outside of the computer screen, you see what happens is there is a centrifugal force that tries to drag this vehicle out of the center. Okay, now once you are going to uh, elevate it or super elevate it, what happens is a component of the weight is going to support this centrifugal support in the sense to resist this centrifugal force. That is why, so you can refer this 9.03 and see the calculation, so how it is being calculated and things. Okay, so anyway, when it comes to the super elevation, what you have to think is the curves are being super elevated to provide that force necessary to counterbalance the centrifugal force. Okay, right. Yeah, now what we have to think in super elevation is, now you know this is the normal ground, right? So this is a road surface, you know this is the normal ground. Now all in a sudden you cannot come to the full super elevation like this, then what will happen? There will be a step on the road. Okay, so therefore what we do is we do it gradually. Okay, from minus 2.5 to 0 it comes gradually, and then say this is plus 2.5, and from 0 to plus 2.5 it again comes gradually, and from plus 2.5 to what 0 again, and then from 0 to minus 2.5. This is how the super elevation is being uh, developed. Okay, so for the super elevation, uh, to get from normal cross fold to full super elevation, there is a length. That length is considered, that length can be calculated using two methods. One is relative gradient method, other one is rate of pavement rotation method. Okay, so when it comes to relative gradient method, the L is the superelevation development length, so that is that comes to W into E plus N divided by GR. W is the lane width including the hard shoulder. So if your lane width is 3.5, hard shoulder is 1.5, W is how much? 5. Okay, so E is the superelevation that you are going to provide, say 2.5. N is the normal cross fall, that is also 2.5. So then relative gradient, so you have to refer this table. If your design speed is 50, your that is one lane to one side, so your relative gradient is 0.71. So you can apply there and calculate the relative according to relative gradient method. And for the pavement rotation method also, here E is the super elevation, N is the normal cross fall, V is the design speed, and beta is the rate of pavement rotation. So rate of pavement rotation is 0.035 for design speeds less than 80, and it is 0.0254 design speeds greater than or equal to 80. Now one thing, a rule of thumb that you have to remember, for all the design speeds lesser than 80, relative gradient method has the dominance. So that means the maximum value is coming from the relative gradient method. For design speeds greater than 80, rate of pavement rotation method has the dominance. That means the superelevation development length that you are going to calculate using the rate of pavement rotation method will be high for speeds greater than 80 kmph. Okay. Mm. And you have to consider about a little bit of jargons. So I'll show you. This is the super elevation development diagram. Now just think about this curve. You are coming this way, so this is turning anti-clockwise direction. Okay, anti-clockwise direction. So if it is going to be anti-clockwise direction, which side should be elevated? RHS or LHS? That you are going this way, huh? RHS, right? Now just think, now in the childhood what you did was you had a ball and you tied some string there and then you rotated it around your head. Now what happens? So the ball is trying to go go out, or trying to come towards you, go out. So what you do is, using a string, you are resisting that force. Okay, so with the tension of the string, you are resisting that centrifugal force. So if you are turning it this way, then what happens? So it is trying to go out of the curve. Then what happens is, you have to elevate the right hand side. If it is other way around, if it is like this, then you are turning in clockwise direction. Then which side should be elevated? LHS. So this time it should be LHS, right? Here it is RHS. Now you see, now they have provided a super elevation greater than 2.5. Now usually our normal crossfall is minus 2.5. Here say 3%. Now see how the super elevation development is taking place. Now for the first, we'll discuss about the LHS side. Now here RHS side should be elevated, that's clear. And we'll discuss about LHS side. It's coming like this. And for the RHS, what happens is, it starts elevating. Now in the river, so the point that starts there, we are calling ENC, that is end normal crown. Okay, end normal crown. That means the normal crown ends. Okay, normal crown ends. After that, super elevation is starting. Now RHS side, just think about RHS side. RHS is gradually increasing, but for the same time LHS side is not changing. Okay, it's coming like this. Finally, when it reaches, now here the RHS side reaches plus 2.5, it is this place, reverse crown. After that, what happens? LHS side also goes down. Okay, now if you are going to put a mirror here, this part and this part are the mirror images. Understood? This part and this part are the mirror images. Then it reaches say 3% or 4%. Now within the curve, it continues. And finally what happens is, it again starts going down. And when you are coming here to plus 2.5, what happens to this LHS side? It reaches again plus 2.5, and then it continues, minus 2.5, and then it continues minus 2.5, while RHS is coming down to minus 2.5. So it meets the LHS again in B and C, begin normal crown. Again the normal crown starts. Now if you are considering according to Ostrov standards, now from ENC to BFS, you call it the super elevation development length, LE, super elevation development length. From ENC to BFS, it is super elevation development length. Now according to Ostrov's, you are keeping 1/3 of this LE inside the curve. 2/3 outside the curve. Now you know in natural roads we are considering Ostro's method. Ostro's we are using 1/3 of superelevation development length inside the curve, 2/3 outside the curve. But if you are going to use Astro, that is different. So there they are having two parameters called runout length and runoff length. So they are keeping runoff length, runout length totally outside the curve, and 2/5 of runoff length inside the curve, 3/5 of runoff length outside the curve. So outside you are getting full runout length plus 3/5 runoff length. That is Astro. So I'm not going to describe it here. I just told because otherwise, when you see an expressive or something, you will be confused why it is like this. But for the natural roads, of course, it is easy. We are having 1/3 of superelevation development length inside the curve, 2/3 outside the curve. So you have to know these jargons: ENC, N normal crown. Okay, so that means your normal crown is going to N. And here reverse crown. Reverse crown means that the lower section, that can be LHS or RHS depending on your curve, the lower super elevation value, so the lower section of the super elevation, lower side, it is going to change the direction. That is why it is called reverse crown. And the begin full super is, full super elevation is going to begin. And then we are having EFS, N full super. Okay, full superelevation is going to end, and again we are having RC, that is reverse crown. We are going to change the superelevation direction, and then finally begin normal crown. Okay, so there are some equations that you can calculate these values. Okay, and that is for a simple circular curve. That means you are having only one curve. There are no other curves in the vicinity. Now, when it comes to reverse curve, you know this is uh, clockwise direction. This is anti-clockwise direction. Now for the clockwise direction, which side should be elevated? Huh? Left. Okay, in anti-clockwise direction, right. Then what happens? Can you see that super elevation directions are being changed? Okay, here. Now at the tangent point, super elevation becomes 0. Understood? Yeah, also you can calculate using these things. And now closely spaced compound curve. Sorry, reverse curve, closely spaced reverse curve also. Now this is, you see, this is anti-clockwise direction, so RHS should be elevated. This is clockwise direction, LHS should be elevated, but here there is no common tangent point. So the common the place, the level crown, or the crown, or the place where you are having both elevation, super elevation 0, that point, that comes depending proportionately to this length. So how to calculate these proportions depending on these equations. Okay, and compound and closely spaced compound curve, again it is, because you see here it is clockwise direction, so LHS is going to be elevated. Here also clockwise direction, LHS is going to be elevated. And therefore LHS elevation is coming, but only thing is, now this super elevation can be changed. This may be 3% and this may be 2.5%. This may be 5%, this may be 3%, or this may be 3%, this may be 5%. Then what happens is just like that, you are coming from RHS to LHS, same thing. Okay, there also you can calculate based on these equation. Sorry. Now with that knowledge, we are going to provide uh, super elevation development to this alignment, super elevation development. One thing is, you have to calculate LE. Now I am not going to calculate LE, but if you really want, you can calculate. Okay, so we'll just take calculator. Okay, what is LE? LE equals W into E plus N divided by GR. Agreed? Okay, so what is your W? Tell me. 3.5 plus 1.5. That is 5. 5 into E. E is super elevation. Say 2.5. Then normal cross fall is again 2.5. Okay. Ah, strong. It's wrong. 2.5 plus 2.5 into 5. Then divided by how much? Again, I will have to show that. That is LE into E plus N into V divided by, sorry, the first one. W into E plus N divided by GR, right? E is 2.5, N is 2.5, that is 5. 5 into 5, 25. GR is relative gradient. Relative gradient. Say in our case it is 1 lane. Our design speed is 50, so it should be 0.7 now. Divide by 0.7 now. How much? 35. Say we are going to round this off into the nearest 3 meter. Why? Then 2/3 and 1/3 are easy to take. So we'll say it is 36. Okay. Now I am not going to calculate it any further. I am always taking this as 36. But in reality, you have to calculate for each and all the curves. Right. So how we are going to insert super elevation? Please do it with me. Okay. Any questions so far? No. Now another thing is you have to refer this table. Which table? You have to refer this table. Now check your here. Check your curve radius. It is 35, right? So 35 is, it is 30 design speed. This should be the curve superelevation should be 2.5. Okay, your radius is 35, right? 35 only falls there to design speed 30 and radius 3.5. Now if you want, you can actually calculate how much it should be. The superelevation development length you can calculate. How? Using this equation. Okay, if you want, you can calculate. Just check W. W is 5. 5 into again 5. Why? 2.5 plus 2.5 divided by 30. How much GR? 1. So it is 25. Then we are going to take 27. Okay. Then take the next curve. That is 78. So where does it fall? 78. Depending on the table, right? 78 falls for 40. Okay. 42.5. Okay. 42.5. Otherwise 50, 10%. We are not going for 10%, right? So therefore it is 42.5. Then how it comes? Then how it comes? W. W is 5 into 2.5 plus 2.55 divided by GR, that is 60.63. Did I say 60 or 40? 40, isn't it? 25 divided by 0.83. That is 30. Then it comes to 33. So it is how it comes. Now we'll, as a, for this one, we'll consider 1 LE throughout. Otherwise, it is very difficult. We have to calculate every time for the lesson, right? Then, but of course, if you are going to do it, if you are going to do a real design, you will have to calculate it for each and every curve. So we'll take 33 throughout. Agreed? Okay. So we'll insert the super elevation. How? General tool space. So you go to prospector and under sites, site 1, alignments, center line alignments, you have this DCL. Please come to this place. Okay, so you have to come to prospector and then go to sites, site 1, alignments, center line alignments, DCL. Then right click, edit super elevation. Edit super elevation. So there are several methods. One thing you can do is calculate super elevation now. Now calculate super elevation now you can use if you are in America or Australia. Okay, but since we are in Sri Lanka, we can't use that because they don't provide our standard. Okay, if you are in America, of course, America or Australia, you can refer that table. Okay, but unfortunately, in our case, we can't use this calculate superelevation now. One thing we can do is open superelevation curve manager and then give manually. Right, but I will show you if we are going to go for calculate superelevation now, how it is going to, so what you are going to see. So we'll go to calculate superelevation now. So you have to give these parameters. Out of these four diagrams, what describes your road best? Is it undivided crown or undivided planar, divided crown with median or divided planar with median? What describes your road better? Yes, 1 or 2 or 3 or 4. Quickly you have to give me the answer because you know. Normal roads? Huh? Undivided? Undivided crown. Yeah, that's undivided crown. In our country, almost all the roads are undivided crown. But when it comes to four lane road, that is divided. Okay, but is not here. So we'll select undivided crowns. Then lanes. Normal lane width is how much? Here number of lanes, right? 1. Okay. Normal lane width is 3.5. Normal lane slope is minus 2.5. Then shoulder control. Outside edge shoulders. Normal shoulder width is 1.5. Normal shoulder slope is how much? 2.5. Not they are talking about hard shoulder, not soft shoulder, right? Then shoulder slope treatment. So this one I will have to describe. So we'll go for match lane slopes. Later I will describe what is them. High side also default match lane slopes. Then go to next. On here transition formula. Here design criteria file. Here you can select. Okay, so you can see what Autodesk Civil 3D metric, roadway design standards, roadway design standards, roadway design standards, roadway design like metric roundabout presets. Now you have to select one. None of are Sri Lankan standard, but anyway I'll select the latest one, right? Say open. And on tangent, for tangent curve, how much is the super elevation? On tangent, it is 2/3. Okay, that is 66.67. That's okay. On spiral, if there's a spiral between the straight and the curve, then 100% is going to the spiral. That is a theory, right? That's a theory. If there are no spirals, you take 1/3 inside the curve, 2/3 outside the curve. But if there is a spiral, 100% superposition development is coming inside spiral. So this is correct, right? So you go to finish. Now can you see that it is a mess, right? It's a mess. But you can remove this. Now purposely I did this. Now if you want, you can remove this confusions. Okay. To do this, we'll again do it, right? So you go to this DCL, go to edit super elevation. This time you go to tabular editor. And can you see this one? This like say road and there is some cross clear all super elevation data. Okay. So you can clear all super elevation data here. If you press this, all the super elevation data will be gone. Okay. Right. Then again you can go to DCL, right click, edit super elevation, calculate super elevation now. So I am again going to give the relevant details. Okay. This is undivided crown. Next. Here normal lane width is 3.5. Normal lane slope is minus 2.5. Number of lanes right is 1. Then press next. Normal shoulder width is 1.5. Normal shoulder slope is minus 2.5. Shoulder slope treatment, match lane slopes. He also match lane slopes. Next, here the alignment method is also there, right? And here I can put automatically resolve overlap. That means there will be no overlapping like we saw in the last time. Okay. And then press finish. Now see, now this is okay. Now this is okay if we are following whatever the standards that is being used. Like say roadway standard 2018 or something. If you are going to use that, then this is okay. Okay, but unfortunately we are not using that. Okay, therefore this super elevation is this super elevation development. If you are going to provide this, it's wrong in Sri Lankan context. Okay, maybe in American standards this is okay. Understood? Now please remove this again, right? Edit super elevation, go to tabular editor, and here you can remove all the data. Right, now we are going to provide super elevation using the manual method. Okay, using the manual method. Now before going for manual method, we have to come into some agreement. Okay, otherwise of course you will have to calculate for each and every curve. Now I propose that we come to an agreement. Our LE is 33. Okay, then we don't have to calculate for each and every curve. But in reality you have to calculate, right? So please understand. Okay, so we'll go to manual calculation. You go to this DCL, site 1 alignment, centerline alignment, and then DCL. Right click, edit superelevation. Okay, then open the superelevation curve manager. Then you go to tabular editor, right? And then we are going to now select curve 1, and here can you see, yeah, you can right click and give to add station, add station. So what is the first station that we have to add? 0. Okay, because we have to provide super elevation throughout, so it should be 0. Enter. And now if you expand this curve 1, there is transition region, expand that also, there is a manual station 0. That's the one that we what that we added. Okay, so there is nothing called super elevation starting location or anything, therefore we'll add you can under manual station you can right click, assign critical station, you can add begin normal crown. Manual station, right click, assign critical station, begin normal crown. Okay, then there's a glitch in the software, you know it is not coming here, right? So what you can do is you can tick it and come back again tabular editor. Okay, now it has come begin normal crown. So here all these things you will have to give the relevant values. Left outside shoulder minus 2.5, left outside lane minus 2.5. Now what is this one? Rate of change we don't want. And what is this one? Curve smoothing we don't want. Remove that. Remove in the sense you bring it here. Left inside lane minus 2.5. Left inside shoulder also minus 2.5. Right inside shoulder, you have to give 4 values, right? Right inside shoulder plus, sorry, minus 2.5. Right inside lane minus 2.5. Right outside lane minus 2.5. Right outside shoulder minus 2.5, right? Now if you tick this and go back, then you will see here it has come to minus 2.5. Then as a rule of thumb, what we do is we are entering the same values to the last chain edge. Okay, now when you are entering last chain edge, always take 2 decimal values. Okay, don't go for the third one, it will not consider. So you go back to tabular editor and go to the last curve, add station. So your station should be 2437 plus 81. Enter. So here curve 20, transition out region, manual station, that is 243781. So you can select manual station, go to assign critical station, N normal round, N normal round. Again it is not being shown due to that glitch. So you can tick this and come back tabular editor. Okay, then it has come N normal round. So you have to give all these 8 values here. Left outside shoulder minus 2.5, left outside lane. Now if you want you can copy and paste. Control C, Control V, left inside lane also, Control V, left inside shoulder also, Control V, that is minus 2.5, right inside shoulder also, Control V, right inside lane also control V, right outside lane also control V, right outside shoulder also control V, minus 2.5. Then you can tick this, and if you go back to your diagram you can see everything has come to minus 2.5. Okay, so we didn't do anything yet, we just entered a baseline. Okay, that's all, we just entered a baseline. Now we are going to uh, enter super elevation development for this curve. Okay, so please remember, time to time you have to save the drawing, nah? Right, now we are going to now we should know the chain edges. What is this chat? What is the meaning of inside and outside? Now you know, have you seen in expressways there are two shoulders? Okay, when you are uh, going along the expressway, in LHS side there is a shoulder, in RHS side also there is a shoulder. So whatever that is near to the center line is an inside shoulder. Whatever that is at the edge of the carriageway, that is outside shoulder. Now in Sri Lankan roads, we usually do not provide, even for 4-lane roads, we usually do not provide inside shoulder because our acquisition are limited. But in other countries, sometimes they provide, especially in UK motorways, you can see there. But anyway, when it comes to this software, you have to give all the details, right? So we'll go to now first we'll calculate, right? Now you know it is 33. So 33, one third of 33, how much? 11. And two third is 22. Okay, so here the curve starts at 73. Take the nearest integer, right? 73. 73 minus 22, how much? 51. So your normal round is ending at 51. Okay, so you go to tabular editor and under curve 1 right click, add station. So the station should be 51. Okay, again manual station, you can right click, assign critical station, n normal crown, n normal crown. Okay, so now you can see it has all automatically come. Okay, if you go to tabular editor and see, you can see in the end normal crown you don't want to enter anything. Why? Because at the beginning also it is minus 2.5 throughout, at the end also it is minus 2.5 throughout. So it has interpolated, and now you don't have to enter anything here. Okay, so that is one advantage when you are going to enter start and the end at the beginning, right? Okay, then 51 plus 33, how much? 84. 84 is the begin full super. At station 84. Manual station, right click, assign critical station, begin full super. It's not coming, right? Just because of this glitch. So you go to I, then see which side should be elevated. It's clockwise direction. Which side should be elevated? Huh? It's coming this way. LHS, right? So the LHS value should be plus 2.5. Understood? 2.5. So I am going to copy all these values to LHS side. Okay, now can you see that it is being given here? Right? So okay, save the drawing. Now other side again, 11 inside, 22 outside. 11 inside means 110. We are still under the first curve, right? At station 110. 110 transition oxygen, that is n full super. N full super, because we are going to end the full super elevation. Okay, so again we have to tick and come back. Right. Here we have to give because it has interpolated. 2.5 plus 2.5. Right. Now can you see that 110 has come here? So we are going to add 33 there. Then 143. Okay, tabular editor. Under the same curve, at station 143. Right click. Begin normal crown. Begin normal crown. Okay, so we have to tick and come back. Okay. Begin normal crown. So everything is minus 2.5. So RHS side you don't have to do because it is already been filled with the correct value. Now how is that? Save the drawing. Your super elevation is being entered. Okay, then shall we do another curve? I'm not going to do everything here manually. Yeah? It will be very tiresome. So we'll do this. We'll do these three curves because then you know. Now it is 78. Now check 78. Because you have to find out which super elevation you are going to give using that table. 78, of course you will have to go for 40 kmph. It is above 40, above 60, so it will be 2.5 super elevation, right? So we have agreed that we are going for 33 super elevation development length, right? Then this is 215, 215 minus 22, 215 minus 22, 193. Okay, so it should be edit super elevation, tabular editor. Now we are trying to do this under curve 2, right? Add station, then 193, 193 transportation manual station, assign critical station. What should be that? N normal crown, N normal crown. So you don't have to do any changes there because minus 2.5 has already come. Okay, here then 193 plus how much? 33, 226. Tabular editor, right click, add station, 226. So that is begin full super. Here it is counterclockwise direction. Then RH should be elevated. Okay. So here 100, yeah, 226, while LHS is minus 2.5, RHS of course you will have to set as plus 2.5. Okay, now just think about here. Here we are getting 55. See 55, what we have to do? It is 4%. Okay, it's 4%, right? It's 4%. Then you have to give 4% here. Then of course you will have to calculate using those equations. Okay, but anyway I am not going to calculate using these equations because this is not a theory class, right? So what you can do is uh, we'll assume that superelevation development length as say 12 meters or something like that. Okay, so we'll put we'll put 8 here, 4 here, just to show that how we are going to enter it, right? So it is, if it is 33.335 minus 8 is 327. Okay, then we'll go to add station 327 n full super. Okay, 327 n full super minus 2.5 is okay. It should be plus 2.5. Then 327 plus 12, how much? 339. So that's the curve number 3, right? At station 339 under curve 3, that is begin full super. Is there any change in the direction? No. Why? Because it is a compound curve, right? So this is begin full super of that curve, right? So here RHS has to be 4. RHS has to be 4, right? Has to be 4. Oh, this LHS, sorry. LHS has to be minus 4. And RHS has to be plus 4. And if it is 4%, of course this LE or the superelevation development length will be increased. You have to calculate it. Okay. Earlier we got it as 33. Now this time we will take it as say 39. Okay. I don't know. It can change. You have to calculate and check. Okay. If it is, what is this question? How we round off the values of stations? You have to take to the nearest integer. Okay. So I'll take it as 39. Then one third of 39 is 30. Yeah, 30. Then here 373.50 say 53 sorry 53, we'll take it as 374, sorry, 374, then minus 13, 361. So under curve 3 at station, what is that value? 361. 361. Then you have to go for n full super. Okay. So again it will be minus 4 throughout for the LHS. And plus 4. Okay, after that what you have to do is you have to provide begin normal crown. So that is plus, we said 39, right? 400. So you go to add station 400. So that is begin normal crown. Okay, begin normal crown. Then that is minus 2.5 throughout. Now it is correct. Hmm? Have you ever seen that super elevation being changed like this? Huh? No, it has to go there until it reaches plus 2.5. Okay, then only it has to go down. Okay, so actually you have to calculate it, but I'll just take some value, some say I'll just use some designer's tricks, because otherwise I have to calculate. Okay, so we'll say it as 361 plus 12, we'll say 373. Here we'll give reverse crown. Okay, 373. Here after n full super at station 373, that is assign critical station reverse crown. In reverse crown, this one becomes minus 2.5 LHS and RHS becomes RHS becomes what? RHS becomes plus 2.5. Now what do you see? Now this is not a straight line. Okay, now this is not a straight line. Now if it is a straight line, it has to come from here to here. Okay. Now if I want to make this a straight line, what do I have to do? This is a designer's trick, right? Without calculating how to do that. Okay, of course if you want you can calculate. Now I just assume it as 12 meters and now I see it is wrong. It's not 12 meters. Now if you want to take this here, what you have to do? You have to, if I take it here, what will happen? Yeah, that will be distorted further, right? So I'll take it this way. Instead of 373, I'll give 370. We'll see what will happen. 370. 370. Now it's okay, right? Now you didn't calculate, but it came. Now one thing you have to do is, if it is 10, now that means 10 meter is okay for the reverse crown, then this one should also be 10 meters. Okay, so you can change. These are some little tricks, right? Otherwise you have to calculate everything. Okay, right. So that is the end of super elevation using manual method. So